Standard 3.3, simplified trig expressions using reciprocal and Pythagorean identities. Okay, so for this particular standard, you want to have your formula sheet out so you can see where the substitutions are all coming from. Go ahead and pause the video and take out your formula sheet, and then when you're ready, you can go ahead and resume. Now, our job is to simplify each of these trig expressions, and basically what we're going to do is use substitution and algebra to come up with a simpler expression than the one that we're starting out with. Now, everyone is different, so there's no one way to the right answer, and there's no set of rules that you could follow every single time as well. So you might find that you are trying something and it doesn't work, and then you're trying something else, and that's fine. All right, so our first example is sine A times cotangent A. Now, one of the rules that you can use, and again, this is not a hard and fast rule, but it's kind of a generalization, is to change everything to sines and cosines, okay? So our strategy here is going to be the following. Strategy, change to sine A and cosine A. All right, now there's two pieces. We have a sine A and we have a cotangent A. Okay, let's examine our sine A first. There really isn't anything to change because it's already in terms of sine. So we're going to leave sine A as sine A. Now cotangent A has two possibilities. Cotangent, and there's multiplication between them. Cotangent A has two choices. Your first choice is to change it to 1 over tangent A. And your second choice is to change it to cosine A over sine A. Now, keeping the rule in mind, we probably want to use the second option rather than the first one. And notice in the second option, you have a sign which matches up with the previous sign, so there might be some kind of simplifying that we can do there. All right, so we're going to choose option 2. So here is our simplification. We're starting out with sine A, and we're multiplying it by cotangent A, which we're writing as cosine A over sine A. And since that's a fraction, let's make sine a fraction as 1. Okay? When we multiply fractions, we're going to multiply across. So that becomes sine A over cosine, sine A times cosine A over sine A. And common factors in numerators and denominators cancel out. That really reduces to 1. So all we're left with is cosine A, which is a simpler problem than what we started out with. So to simplify completely, you would be left with cosine A. Let's look at our second example. We're going to use the same strategy. So we have 1 minus sine theta, and the only substitution that we really have for cosecant is 1 over sine theta. Now notice we are dividing here by this fraction. And so when we're dividing by a fraction, we're going to change it to multiplying by its reciprocal. Let's leave the 1 alone. Let's leave the minus alone. Let's leave the sine theta from the numerator alone. So let's just color code. That sine of theta is right there. And what we're going to do is we're going to change 1 over sine theta, that's division to multiplication, and the fraction to its reciprocal. So sine of theta over 1. And so to color code, this divided by 1 over sine theta becomes times sine theta over 1. Again, what we're doing there is multiplying by the reciprocal. So when dividing by a fraction, change to multiplying by the reciprocal. So let's see what our problem becomes. We still have the 1 minus, and if we multiply, you can put this over 1 and multiply across. That's sine times sine. That's sine squared theta. The over 1 is negligible. Now, if you look in the Pythagorean identity box, 1 minus sine squared theta is equal to cosine squared theta. And so that's as simplified as we can make it. All right, let's take a look at, actually before we do that, let's write another strategy down. So another strategy that we used here is when you see squares, like this exponent, when you see squares, search through your Pythagorean identities. So that square there should be indication that you want to use your Pythagorean identity. All right, let's take a look at our next example. Now our next example, let's follow we don't see any squares, so we're not going to use the Pythagorean identities, but let's use our rule of changing to sines and cosines. So secant becomes 1 over cosine x. Let's leave cosine x as cosine x, minus tangent x becomes sine x over cosine x, all over cotangent, which is cosine x over sine x. Okay? And let's use this idea of multiplying by the reciprocal. So we're going to leave the numerator alone for 1 over cosine x, and we're going to change this division right here to multiplication and change the cosine x to its reciprocal, 1 over cosine x. And the same thing for the second fraction. We're going to leave the numerator alone and change this division to multiplication and this fraction that we're dividing by to its reciprocal, sine x over cosine x. All right, now let's multiply. So order of operations is we're going to multiply the first two terms together. So that's 1 over cosine squared x. And we're going to multiply the second two terms together, sine squared over cosine squared. All right, that looks good, but now we have some squares there. So let's see if we can use our Pythagorean identities. Well, before we use our Pythagorean identities, you might want to note that these two fractions have a common denominator. And when fractions have a common denominator, you can combine their numerators using addition or subtraction. So that becomes 1 minus sine squared x all over that single denominator of cosine squared x. Now using our Pythagorean identities, 1 minus sine squared is cosine squared x. So we have cosine squared x over cosine squared x, and that reduces to 1. So our final simplified answer is just 1 there. Again, every problem is different, so some of the rules that we use, some of the strategies are to convert to sines and cosines, changing to multiplying by its reciprocal when you're dividing by a fraction, when you see the squared, use your Pythagorean identities. And again, you might hit a roadblock and you have to reverse and try again. That can happen. That is standard 3.3, simplifying trig expression.